So in part B, we're given the distances of the points. We need to derive an expression for the tension in the horizontal string. So what we need to do here is write up an equilibrium reaction equation. And well, the easiest one is the torque one here. So we can write up the torque about the pivot so that we don't need to determine the magnitude and the direction of the pivot force, as the force itself passes straight through the point we're going to write it about. Therefore, this force has no torque around it. Therefore, we don't need to include it in our torque equation. So we have three forces that have a torque around this axis. We're told the distance from the axis to P is 3 over 8L. And so what we can say is that the torque is simply going to be the force, which is 3 times m times g, and then times this distance from the force to the pivot. So we need this perpendicular distance here. If we know that this angle is theta, then it will be 3L over 8 times the sine of this theta, as we need this perpendicular distance. Same for mg now, only that this will be 4L over 8, as it's midway. It's exactly in the middle. And finally, for the tension force, we can again consider the triangle. So we have the tension force like this. And so what we need is this distance over here, which will be the cosine of this theta, is the adjacent side. And it's rotating the other way. So these forces want to rotate this way. This force will rotate this way. So minus Ft times 6L over 8 times the cosine of theta. And since we have equilibrium, it will be equal to 0. Just like this. And all we need to do now is rearrange. So we can bring the negative to the other side and we can divide by L. We have 9 over 8 mg sine theta plus 4 over 8 mg sine theta equal to 6 over 8 ft cosine theta. We can combine these and divide by 6 over 8 and cosine of theta. So then we get that the tension is equal to 13 over 6 mg tan theta.